principles of autonomous computing really start to show in how people conduct their businesses?
You want to go first?
I could go first on that, actually. So let's unpack some of the things in your question. So you talked a little bit about autonomous. Now, much of software, when you're building software, involves dealing with very complex systems. I mean, what looks like a fairly simple user interface to people who use apps, right? It's by design simplified up front. However, behind the scenes, there is a lot going on, and people are building in, distributed architectures, highly scalable architectures, and to do that piece by piece, it takes a lot of toil. And to watch all of that and make sure that system is working well together takes a lot of toil. And when you're thinking about autonomous systems, to me, that is creating and building essentially what we call a platform to tie it all together, right? And create certain contracts between all of the things that need to work together and make it super easy for developers to understand what that interface is and just sort of push their creation onto the platform and let the platform sort of do its magic and take care of the rest of it. That sort of removes all of the toil from the equation, and it brings that, in some ways, more meaning to what's actually running on the platform, because that's what the developer ultimately cares about and what the business eventually cares about. Now, when you're talking about serverless, now with enterprises, I think their portfolios are pretty wide-ranging in terms of the kind of applications they run, fairly heterogeneous, which is an understatement. So for these multiple types of workloads, not everything fits that model where, hey, you push it with a certain architecture, let everything take care of it. The degree of control that you might want to maintain for different workloads is going to be different, right? And there are some where it's sort of, push your app and let it go, and there are others where you might want, higher degree of control, where, for example, when you're looking at Kubernetes, let's say, or you might want something that you want someone else to completely run for you, and you just want to put, like function service, like serverless that you were talking about. So having that kind of mapping where you are able to provide the different levels of abstractions for different kinds of workloads is, I think, where you really want to be going forward for enterprises to maximize that productivity that you want for your developers.
But when we think about Cloud Foundry, right, it's a very opinionated platform.
Mm-hmm.
I mean, and Kubernetes has historically not been an opinionated platform. Mm-hmm. How do you marry those? How do you marry that in terms of helping customers think about autonomous computing and moving forward?
Yeah. So the whole idea, I think, behind autonomous computing for me really started with DevOps. So DevOps for me was like the first step in a journey towards autonomous computing, not an end goal. So we had Dev and Ops suddenly talking to each other, and it was two totally different mindsets. Because the developer thinks, okay, if I can write code to handle something, then I'm going to write code. I'm not doing it a second time. And if I can fully kind of automate it, I'll do it. Operations people historically wanted to have responsibility for your environment, wanted to be deeply involved, wanted to have control, which was good because obviously you have to control of your production environment, but they just learned from each other that, okay, so why are we doing a script, or in the very beginning even on cloud computing, why are we SSHing into machine? To just fully automate this, just put it into code. When we started to talk about infrastructure as code somehow. And I think also operations learned, well, if you follow this approach that developers are offering us, we're not building one-off solutions. We start to build an ecosystem for things to happen. Like we become like bigger than the sum of the parts. And then something started to happen that we also saw internally at Dynatrace, where operations became an enabler by providing a platform or an ecosystem for people to build something on top of it. And then these interesting conversations emerged. So if we have infrastructure as code, if we have a platform that can handle something automatically, why can't we make runbooks as code? Why can't we make remediation as code? Why can't we make performance as code? Why can't we make security as code? And suddenly we started to build all of these new components, and that the way how self-healing comes in there was also what we learned internally when we got developers more and more involved into the operational process, which you do with microservices, like this, following this paradigm of you build it, you run it. A developer might, or a more traditional operations person might say, well, we create a runbook entry for this. A developer would never do this. He said, I don't want to write a wiki page. If this is how it failed, I'll write code for it not to fail in the future. So the whole idea of autonomous computing is not that these are magical platforms that are built on, well, there are some great technologies, like we use AI for problem detection and so forth, but these are not magical platforms. This is just these two mindsets kind of interacting with each other and really creating something new. The key piece, however, back to Cloud Foundry and Kubernetes now is what we also learned, like we learn a lot on the APM side, that people stopped really looking at dashboards and starting to see APM as a platform as well. Again, operations people looking at dashboards, executing runbooks. Developers looking at an APM platforms, asking, what are the APIs? What can I do with it? What can I do with this information? Are there webhooks? How can I interact with it? Starting to build something on top of it, because even we at Dynatrace, where we provide the ability to find the root cause of a problem, need a platform that can do something with it. If you still have to use FTP or SSH into a machine on an app that's totally bound on one machine that you cannot scale up, where you cannot roll back, it doesn't help you to know which remediation actions you want to take, because your underlying platform is not ready. That's why we also compare this to like a self-driving car. Obviously you need the hardware, you need the actual car that's able to be remote controlled, and you need the software. If you only have one of those two pieces, it's not going to work. And both platforms in different ways, Kubernetes and Cloud Foundry, provide those abilities, whether it's a fully cloud-native application on Cloud Foundry, or what we also see customers use Kubernetes once they have the 12-factor applications for their more traditional stacks, where they want to have the same abilities. It really are two flavors for two different problems. But for us, we can tie into both platforms because they both provide these capabilities to be controlled via an API, and we can have this interaction. Let's see it more or less as the next step of DevOps in code, maybe, to have a working title there.
Does this lead to, we were talking earlier about no-ops. Is there kind of a tendency to move that more towards really this very thin operations layer, where we're starting to see where where people will not be as critical to the process in terms of the numbers of people that you have, and we'll see more of a focus on this whole concept of no ops, but maybe not quite in the thinking that the term implies?
Well, I think the coverage of the word no ops really is referring to a lot of different things, and I think certainly we can take out some of the operations that I was referring to the word toil before, right? So it really has been a lot about automating all of the things that machines can handle, right? So that the focus essentially shifts to doing the things that actually require human interaction, communications, and with each other and with the machine, right? So from that perspective, I think yes, we are sort of moving directionally towards a no-ops, more and more no-ops, but I think it's still essential that someone is looking after what's going on behind the scenes, because ultimately when something goes wrong, you do kind of need certain, as I said, complex systems will require certain humans to come in and figure out why that is the case and fix the problem from a development point of view, right? There are a lot of things, for example, you can push into, like, say, self-healing systems, recovering an application after it has failed, recovering a VM after it has failed. So these are things that you can essentially push into the platform, right? You don't have to do that for a majority of the cases anymore, but you still want to find out why, right? Why did it fail?
So these self-healing systems that we talk about, right? And these are, what are these now? What does that mean to you? What is this? I mean, we heard more about this term. What does self-healing mean to you, always?
I think self-healing in the very end version of it will really be systems that learn how to heal themselves, and we're definitely not there yet. But we don't have to be there. For me, it really starts that human interaction in resolving a problem should become the exception and not the rule. And there are very well-defined bounds, what you would do, what you would traditionally put into a runbook, what you would put into a script, that you cannot tie deeper into the platform. Like running low on CPU, scaling up something. Deploying something leading to more problems in the application, automatically rolling back a change. We'll start with very simple things, but even those very simple things today have to be done by humans. So we'll see gradually more and more complex tasks being taken over. Like scaling up on resource consumption was really the first bite everybody got, whether it was back in the days when AWS introduced the whole auto-scaling concept. And now we are moving beyond that step by step. And eventually, I think, we will also learn the best practices because we will start to see patterns. So the more we try to do this, we will see a set of patterns. Okay, this is how we usually fix those systems. This is like a standard tool set that we use to recover a system. And as long as we stay within this standard tool set of things that we can do, we can start to automate a lot. We can even have the system learn which of these activities is successful or not. And to Kamala's point, once we move out of this very clearly defined bounds, you will need human creativity anyways. And also the goal for a self-healing system is not to replace operations at all, but we have those business critical applications that are highly complex, and you need to act fast because otherwise you have business impact. So whether it might not even be problem resolution to the extent that it's going to change code or anything, it will still require humans and you have to make those decisions, but just the mitigation, keeping the lights on, keeping the systems running, and keep giving humans the time to build the actual solution for the problem, while still ensuring that the service is up and running is where we're moving towards in a really gradual step-by-step type of process.
So traditionally, application performance monitoring has been about the application, and now we're thinking about managing the components of the application, and it introduces kind of the combined need for not just monitoring, but really this term we're hearing more about is that observability, which is a combination of monitoring, and other dynamics that you're looking at, in the infrastructure itself and how the application is behaving. How do you view that? I mean, you guys are a traditional APM company, right?
We used to be a traditional APM company.
You come from
that background.
You come from deep roots in APM. Pivotal actually comes out of VMware, and EMC, right? It has deep roots in the virtualization, technology world, and in storage and other things as well.
Sure.
But it's a shift, right? It's a shift in kind of thinking. How do you guys think about it internally as a shift in thinking that affects your own decision making for your own internal architectures?
So from my point of view, I think the Pivotal's approach is actually more outside in than it is infrastructure out. Actually, if you think about it, like we are much more about how about the process. The methodology is as important to us as is the platform and what's underneath that as well, right? So from our perspective, the monitoring aspect of it has to inform the methodology aspect of it, right? And so we're thinking about systems as being a continuous deployment cycle. So when someone receives information, whether it is part of the pipeline and you want a notification that something is wrong before it deploys, an application deploys in a production, or whether it is something that is running in production and you want information about the application that is running in production, or components of the application, or the service itself that's running in production, you want that information in a way that that is actionable, right? And you can fix the application with, and react to it. One of the things that we see often with customers is monitoring occurs sort of after the fact, right? Like it is thought of as part of the process that comes once you push an app and then you apply it. It's not always in consideration from the beginning, right? And I think that's one of the reasons this partnership with Dynatrace, has been taking off so well with our customers, is that as the way they deploy the monitoring is along with the application, it's directly available across all of the VMs that Cloud Foundry is running on. And so automatically it's turned on, and that information is streamed to the developers as they see it, and they can react when required. Otherwise, the platform takes care of all the smooth running functions.
How about you? What's your thought?
Yeah, I really like this whole observability movement that's going on in the cloud native space. And what we've also seen is that usually cloud native applications or microservice applications, also from our customers, are usually 20 times larger than a traditional application, just by the amount of entities that are involved, which is good because once you switch from a monolith to a microservice, you break it down, it just gets bigger. And having a monolith being 20 individual services is not obviously that uncommon. At the same time, you're doing it for very good reasons. So obviously people learn, we need to understand how it works. Not obviously at the application level because that's what counts and on the user level, but also all the way down to the entire stack to take informed decisions. And the whole idea of observability is, again, like the next step of DevOps and the whole microservice teams that are end-to-end responsible. You can't build something that nobody understands how to run it, but now it's your problem. In the past, it used to be still in the DevOps world. It was somebody else's problem. You built it, okay, I built some monitoring in there, I talked to my ops teams, but if it breaks at 2 a.m. in the morning, it's still the ops team's problem, whether it's working or not. So, to that point, the role of monitoring really changes, but it's something that's actually very traditional. It's a control system. A traditional monitoring environment was not a control system because you were looking at the data and okay, it's not working, great, but there was no feedback that would directly tell the platform, change this to that idea of autonomy. It was not a full control system, and we're just moving there. And we're creating this understanding right now as people build these enterprise scale applications on a microservice basis, which tend to be really, really large and complex, which is fine. Because as Kamala pointed out, a lot of this complexity is taken away from the user. It is still there behind. So if you would open up the hood, you would see all the complexity. And obviously observability is much more important. Because if you don't have observability, if you don't understand how it works,
it's critical.
It more or less becomes a chaotic system. At least it appears to be chaotic because whatever you're trying to change has consequences that you have no idea why they're actually occurring.
So that's interesting, kind of a story, isn't it? That's unfolding.
Yeah.
Where does serverless start to play into this story? And I think of it more as, my view on serverless is, in some respects, it's like using the resources to perform some function, right? So you can almost like use the resources for event-driven automation, in some respects, right? So if you're thinking about it in those terms, how does that affect kind of your thinking about these enterprise customers who are now who have finally believed and who are finally here and they're like thinking, okay, I accept this. How do you, how is that story unfolding for you in terms of serverless technologies, or is it just one part of it? Because of the overall story around resource-driven kind of event practices.
I think it comes back to the point of the diversity of workloads that enterprises need to run. Certainly some of the workloads will fit the serverless model, and where you want the machine to look at all of the scenarios that come up and fix it itself. And those are the ones that are clearly defined, fairly predictable, and codable into the platform. There are, again, other kinds of workloads that you would want, again, more control over. You may not even decide that there is enough of a return on investment in trying to convert that into that special the new architecture, and those will continue to run the way they run, right? So yeah.
So Always, we talked about serverless, earlier, and you think it makes sense for companies to start thinking about this, right? Because now, if they are going to start looking out 5 years, it is more of a sophisticated approach, saying, well, if we, have waited this long to go to use a cloud service, for example, or to build out kind of a modern application architecture, right?
Yeah, so what we really see that obviously some of the very large enterprises, they are just getting their feet wet on cloud, but the management there is very aware that they're actually behind and they know it takes them some time to get there. So the only reasonable decision is, okay, what's really on the horizon right now? What's just appearing right now? And look at, just assume we're going to use these technologies, even if they're not ready for the mass market or if they're not widely adopted. They know it's going to take them a couple of years to get there anyways. So they are looking across the board. They're starting to work with them step by step because they know they need to catch up and they need to prepare where they have to be in 5 years from now. And we have seen over the last couple of years a change from, okay, we run everything in a VM. We run everything in a container. Mm-hmm. We let a platform decide how to run things to, I don't even care what the platform does anymore for this very specific type of workload. But to Kamala's point, it will always boil down to what type of workload I'm running. And also my perspective, because underneath, we know what's happening underneath serverless. It's not that there is no server. It's more or less code running in a container.
It's how much information the developer needs to know, right?
Yes.
Yeah.
How much the developer needs to know to build an application that provides the value to the user. In some cases, I might need to build a stateful information. I might need to be well aware of caching and optimization. So I will go for a different approach. Mm-hmm. But if I'm just having some input where I'm just transforming data from format A to B, I really don't care about it. Mm-hmm. So it's really how much responsibility the developer or the development team has to take for what the architecture looks like under the hood. And that's more or less the difference. We will still see bare metal applications in some cases simply because it's necessary for these type of applications. But to be fair, a lot of business applications don't require that much architectural insight, and focus on the business function is way more important. So it will be more widespread. We will see everything, but obviously smart companies will focus on knowing as little as possible what's going on under the hood, unless it's really necessary for them. So that's the way I see it.
Absolutely, and I think there's some applications that will benefit from, from the speed to market. Like that's really what's driving this change in architectures, right? So, how can I get features and functions in front of users as quickly as possible? And those applications that you can justify those architectures for, those will be the ones that you will start with, the least, or rather the most amount of abstraction, because you want the platform to take care of as much as possible, right? And then sort of move backwards from there.
Thank you both for taking the time to talk today. I really appreciate it. In learning more about where you are in your progress in terms of working with customers who are thinking about moving forward, who are thinking about self-healing systems and serverless technologies, and this more move to autonomous computing. Best of luck in this spring season as we move forward. I know you guys are going to be very busy, so appreciate your time.
Thank you.
Thank you for having us, Alex.